right. Good morning, good afternoon, good evening, folks. Thanks again for joining us for another session here of the Machine Learning Community Stand-Up, where we talk about all things machine learning within the .NET ecosystem. I'm your host, Luis, and with me today are my co-hosts, Jake and Bree. And we have a special guest here, Michael, who's going to be talking to us about demystifying and basically going through the ML.NET API code base. So for folks who may be interested in perhaps contributing, whether it's algorithms and things like that, and just in general contribution process, right? Michael's going to kind of like talk through that. So Michael, would you like to tell us a little bit about
yourself? Yeah. Nice to meet you, everybody. Obviously, my name's Michael. I've been at Microsoft now just over 3 years, I think. And I've been working on AI stuff probably for about 1.5 years now or so. Not on ML.NET the entire time, but I've been back and forth between ML.NET and various other things. But it is now currently my main focus, what I'm working on, and yeah, I enjoy it. I'm learning lots with it. A lot of fancy stuff, right, with machine learning and AI these days. And I am definitely not the best expert, but I enjoy it and it's fun. So learn along.
Sweet. Awesome. Thanks, Michael. Yeah, and we're going to talk a little bit more about that in a bit, where you're going to show us a few things here. But before we get to that, let me sort of switch over here to my screen so that we can kind of go over a few things that are happening within the community. So Rubik's Code here has a few guides that they put together. One is this one here on classification. So if you're interested in learning how you might go about doing classification and solving classification type problems using ML.NET, there's this guide for you. They go in depth here as far as, end to end, how you might go about it with this particular data set. I guess this is using Penguins, a Penguins data set. I don't think I've ever heard of this, so it looks interesting.
Yeah, we've actually shown the Rubik's Cube one, or sorry, I can say that every time. We've shown the Rubik's Code one a few times, but they just have an ongoing series, which is really, really awesome, and they keep adding new scenarios. So we'll continue adding them as we see new ones.
Yeah, for sure. And here we have another one from Rubik's Code. This was on clustering, and it's the same idea where here it's how can you solve clustering type problems. Let's see, what data set? Oh, again, they're using the Penguins data set. Interesting that they use the same data set for both of those scenarios. So here, the last one that we have from Rubik's Code, they're using this support vector machine, which is kind of used. It can be used for both regression and classification, right? Or so in that sense, they're also using the Palmer's Penguins data set. I have to look into that now. Now I'm intrigued as to what it contains. But yeah, so if you're looking to solve problems using support vector machines or also known as SVMs, you can basically take a look at this guide here and kind of go through it to learn a little bit more about that. We also have a few videos coming to us from our friend here, John Wood. This one is on how you can use the Automl Api to infer the schema of columns. So if you're not familiar with AutoML, the AutoML API, it's essentially this API that's built on top of the ML.NET API that allows you to sort of automate and speed up the training process, the editor and experimentation process of finding what's the right or best algorithm and the best parameters for solving your problem using your particular data set. So one of the things that the AutoML API allows you to do is, instead of you going in and physically telling your model, hey, this is the schema, or these are the data types and the inputs that my model is expecting, you can leverage the AutoML API to kind of infer that schema for you just by looking at your data set. And I believe that that's actually what's used by the tooling to a certain extent to be able to infer. Is that right, Jake? The infer column schema?
Yep, we use that today. We also use something called Pros, which we can show off at a future time for figuring out what your data looks like and how we should interpret it for our models.
Cool, awesome. Thanks. Yeah. So in that sense, if you're interested in kind of doing that and testing that out, there's this video that John put together where you can go ahead and try it out yourself. Speaking of AutoML API, we won't be doing jumping jacks, but we have this other video on thrice training ML.NET. And in this case, what John goes over is he talks about how you can use test and validation data using the Automl API and ML.NET in general to build more robust models. So again, one of the things or one of the goals that you kind of want to, your models to achieve, the models that you train, is that you want it to generalize well, across, especially on new data, right? So if you train it on a particular data set, you want it to perform well, if not better, than on the data that you trained it with, right? So in that case, you might want to use something like validation data and test data sets to evaluate the performance of your models. We have another video here coming to us from CloudGen Verona, which is a 2-hour session on live coding session, where Marco Zamana goes over how you can build a model end to end. In this case, Marco kind of shows off how you can build a machine learning model using ML.NET. But there's this other piece towards the end, I believe. I don't know if I can find it here, where he uses I believe this is a custom vision model that he's using here. So he goes and trains it with cognitive services, custom vision, and then he goes ahead and he goes ahead and exports it to ONNX format, so Open Neural Network Exchange format that can then be consumed inside of ML.NET. Here we have this other sample from, I believe it's Jose Maria Floresazo. And in this session, he basically, for our Spanish-speaking audience, he goes through the machine learning process and things related to how you can go about building machine learning models with ML.NET. For some reason, this is not loading, but here you should see a presentation or the slides for the talk that he gave, along with the code that was presented during that talk. So, if you're interested in, again, for our Spanish-speaking audience, if you're interested in learning a little bit more, you can take a look at Jose's repo here on GitHub. This is a bit of an oldie but a goodie here. ASP.NET Core, Blazor, WebAssembly, and ML.NET. So a lot of folks are thinking of the idea of how can you deploy machine learning models, whether that's at the edge or on the client, so that you're not consuming the resources of some server. And one of the ways that you can do that is by using Blazor WebAssembly and building essentially static web apps, right? Static web pages, using Blazor WebAssembly and embedding your model inside of this application, so that now the inferencing and the predictions are taking place and the resources that are consumed are taking place at the client side rather than sending it over the network to some server. So if you're interested in learning a bit more about how you might want to structure a project using Blazor WebAssembly and ML.NET, check out John, is that? Yep, check out John's post here. About a month ago, maybe a little less than that, there was a community event, .NET Conf 2021, Pakistan. And in that case, what you had was, and let me just make sure that I don't get the name wrong here. I wrote it down because it's not here. There were a lot of sessions, but one of those sessions was basically talking about ML.NET in the real world. And it was presented by Maren Tahir. And I apologize if I mispronounced that name. And she basically went over how you can use, again, ML.NET for real world scenarios and talks through it. So it's at about hour number 4 on the 29th minute. You can check that out if you're interested. Speaking of events, there's one coming up on the 25th of this month. The folks over at the Central Ohio.NET Developers Group are hosting this session with community member and Microsoft MVP, Ed Chaverneau, who will be talking about how you can build applications using Blazor, ML.NET, and Cosmos DB. So if you're interested, I believe that you should be able to go on Meetup and sign up for this event. And it is an online event, so you should be able to, regardless of whether you are in Ohio or not, you should be able to attend this event. Speaking of events and community meetups, if you're interested, you can go on on Slack, if you have Slack, and you can join the virtual MLNet community, which actually was the one that last year around May was the very first ML.NET, virtual ML.NET conference. And then in November, we had our very first ML.NET hackathon. So if you're interested in participating with the community there, we've included it as part of the community links, this link to join the Slack group. So make sure to check that.
I want to add on to that
Yep.
soon we'll be having our second annual virtual ML.NET community conference. So we'll probably make some more announcements on the next show about it. But I think that's going to be did we decide May or April, sometime around then. And the call for content will be coming out soon. So be on the lookout for that.
Yep, definitely. So if you're thinking of, you want to speak about ML.NET, or you want to learn about ML.NET and how folks are using it out in the wild, definitely make sure to keep an eye out and join us during that time. And then last but not least, here we have the .NET Machine Learning repo, which is what Michael is going to be talking to us later today about. Again, thanks for putting the link up. So folks, you can go ahead and check out that link that's sort of up on screen, and that's how you get access to all of the links that we've went over today. So with that, let me just, before we get to Michael and his presentation, let me kind of just go over something that we've been tinkering with and we've been sort of putting together around the deployment story for web applications, and specifically ML.NET web applications, or web applications that have ML.NET models embedded in them. Let me pull up my Visual Studio Code here to kind of show you what I'm talking about. So typically when you're building, or when you are, the way that you go about building web applications, specifically Web API, which is a very traditional, a very common way that a very common way for machine learning models in general, whether that's in .NET, Python, whatever it is that you're building your machine learning models in. A very common way to deploy these models is through web APIs and through web services, right? Now, .NET has its convention, and it has a variety of web applications that you can choose from, and sort of the .NET CLI and Visual Studio make it really easy for you to get started and scaffold a web application, whether that's a web API, an MVC application, Razor Pages, Blazor, whatever it is that you're deploying. The tooling really helps you get started really, really quickly. And again, it's using sort of the standard conventions and sort of the recommended approaches for building these applications. However, when you're using, or when you're building machine learning models and deploying these machine learning models as a web service, sometimes there's trade-offs, and you want to just get the minimum viable sort of application going with perhaps a single endpoint. And you want to be able to deploy your machine learning model as a single endpoint, right? And while there are some ways to do it with the templates, you kind of have to modify those in order to sort of get a more minimal type of experience, even with empty type projects, all right? So what we've been tinkering with is, there's this sort of technique or this technique or practice sort of known as like endpoint routing, which instead of building controllers, for example, if you're following the MVC, the model view controller pattern, or whether you're using, perhaps you have actions and you have code behind for standard web applications. What this does is it allows you to explicitly define the individual endpoints, and if you have like one or two endpoints, it makes it really easy to simplify that process of mapping the endpoints for whatever actions you're performing in a very succinct manner. So in here, what we have is actually a console application. So I started off with a .NET new console application. And you can see here you have your traditional program.cs, which is just a single file here. And what's done here is the configuration piece is done all inside of the main method of your program.cs file. And in this case, you start off with a web host, right? So folks who will build web applications, they'll be familiar with the web host here. And then we just build the default for it. And inside of it, we also do we also perform the configuration, where these are things that you may typically find in traditional .NET applications, starting with your startup.cs file, right? So one is where you configure your services, and in this case, you're registering any services using dependency injection that you may then use throughout the rest of your application. And in this case, we're registering the service called sentiment model. So we're using this method called @sentimentModel to register a sentiment model that we'll be deploying. And then we have our configure method here, which again takes a list of options, and it here allows you to sort of tell it what type of middleware you'd like to use as part of your route processing. And one of the things that we can use here is HTTPS redirection, right? Which means that not only will you have an HTTP endpoint, but you also have an HTTPS endpoint as well. In order to use endpoints, right, and use endpoint routing, we also need to add this use routing option here, set this routing option, use routing option middleware here. Now, what's important here is this route map post, right? And here's where we actually tell it, these are the routes that I want to make available or exposed as part of my web service. And in here, what I'm doing is I'm creating a route that accepts post requests, and it will accept post requests at the predict sort of endpoint, URL endpoint, right? And then what I have here, what I provided is the handler. So whenever somebody hits or makes a request to that predict endpoint, how should that request be handled? Well, we have a predict handler here, which handles that request. And what we do first is we get the prediction engine pool service. If you're not familiar, this is a scalable way for essentially consuming or making predictions using a prediction engine. But it's more scalable in the sense that it creates a pool that's ready to make predictions instead of creating a prediction engine every time that you need to make a prediction. You sort of have a pool of them that are ready to go. And again, it makes it really, really easy to scale for multi-threaded applications. So the first thing is we want to get that service. So that sentiment model service, which is going to be essentially a prediction engine pool service that makes predictions for us. Then we go about just deserializing the input that's coming in from our request. So again, it's a post request. So we're going to have a JSON body in this case. And then we just deserialize it and we deserialize it into the input that the model is expecting. Then we use that sentiment model service and call the predict function on it, given the input that we're getting from the request. And then we just write it as JSON. So we output it as JSON. And that's all that's happening. We're taking a request in, we're parsing the input, and we're using the sentiment model to essentially make predictions. So what exactly is the sentiment model? Well, if you take a look at this sentiment model consumption code here, you can see that it's just a class here. And inside of this class, you have other nest classes, in this case, the model input, which contains what are the sort of the inputs that I'll provide to my model in order to make predictions. In this case, you have sentiment text, which is some text that you give to your model. And in this case, you also have sentiment, though this you're not going to need for predictive purposes, right? You don't need to use this because that's the value that you're actually trying to predict. Now, what gets output, the model output, is three values or three properties: the prediction, the probability, which is how confident is it that prediction is right, and then the score, which is also, again, it deals with the confidence of that prediction. If we scroll down a little bit here, you're going to notice that sentiment model class, we're doing dependency injection. Again, in this case, we're registering our prediction engine pool. That's going to take a model input as input, and it's going to return to us a model output. And we use constructor. We perform dependency injection here using the constructor of that sentiment model class. Then we have this wrapper, which is just a method called predict, which takes a model input as input, and we leverage the prediction engine's predict method to make predictions, right? And we output a model output. And then the other part that makes it a little bit easier and kind of like abstracts away the need to kind of do this is we're using this, we're creating an extension here for our services collection, right? So you might be familiar that this is how you register services inside of your web applications. You have this add sentiment model extension method here, which it does two things. Number one, it registers prediction engine pool. Again, when we tell it, here's the input that we expect and the output types that we expect. And in this case, we're getting this model, which was already trained and it's hosted somewhere on GitHub, right? So you're able to, as part of this add prediction engine pool service, you're able to either load from a URI, right? So if it's at some public endpoint in the web, or you're also able to load it from a file that's embedded inside of your application. In this case, we don't have the file here, so we're just going to pull it down from GitHub. And then once we have our prediction engine pool, which is then used inside of this sentiment model service, we register the sentiment model service itself, right? And what this does, again, it simplifies it when you're registering your sentiment model service for making predictions, you're not registering the prediction engine pool, and you're not registering the service itself. You just have this one line that says services at sentiment model, and everything gets sort of taken care of for you in the back end, right? So that was a little bit of a long sort of winded explanation, but again, it's just something that we're tinkering with. Nothing is definitive. If this is something that you'd like to see, we really appreciate your feedback, and we'd love to hear from you. To see is this something that makes sense? Is this something that you folks would like to use for this particular type of application, right? So when you're deploying a machine learning model to a single endpoint, some of the caveats and things that you might want to consider, though, with this particular approach is you don't get model binding. So there's some things that you typically get with traditional web APIs and standard web applications. Again, like model binding, discoverability through, for example, using something like Swagger and Swagger Gen to generate sort of a way for exposing these APIs. There's a few trade-offs there, but if you're okay with those trade-offs, this might be a way to simplify these types of deployments. So again, we'd love to hear your feedback, and let us know if this makes sense to you and how we can make it better. So with that, let me go ahead and turn it over now to Michael. Let's see. Okay.
Okay. Thank you, Luis. Well, first off, if any of you have any questions, feel free to raise them up. We'd be happy to address them during my presentation or whatever. But Luis asked me to go over kind of like, if I was a new developer getting into ML.NET, what would I, or if I was helping somebody learn about ML.NET as a new developer, what would I go over them? What would I show with them? Going from the build process up to just, useful things in the code. And I thought a lot about this because obviously ML.NET is a fairly large code base. And I ended up coming to a couple of things that in particular for me were the things that threw me off at first and took me kind of a little while to figure out, what's going on. But first things first, build process is pretty simple, right? They already showed the repository, but here it is, right? .NET Machine Learning. All you have to do is clone this repository, and then you have to, don't forget, you need to do the submodule update. Now, I always personally forget to do this, and so my first build always fails. But once you do this, then it's as simple as calling build, and this will run, the default configuration runs in debug build, and for .NET Core 2.0.
Hey,
now,
Michael.
Yeah.
So submodules are usually like links to other repos to kind of make it seem like it's a part of your repo, right?
That is correct. Yeah. So we use specifically one submodule. It's called libmf. It is for matrix math stuff. And so instead of having to write all that stuff ourselves, we can actually just essentially point a link to the libmf repo to the specific version that we need. And so when we call this get submodule update init, it says, make sure that we have the correct version downloaded, make sure that all their code's been downloaded correctly. If you don't do this, you just end up with an empty folder. And so when the build tries to run, there's nothing in the folder. And then when our stuff, tries to build their code doesn't exist and it fails.
And a few questions there. Is this only the first time that I build it, or every time that I'm creating a build, I have to run this submodule update?
So it's only the first time. Well, the first time that you clone the repo. So if you clone the repo in multiple different locations, you'll have to do it for each one of those locations because it actually, like if we come and look in here, it downloads it into this native folder, into this matrix factorization. And so this folder right here is where it actually gets downloaded to. And so if you don't run that submodule update in it, this folder here is going to be empty. And so anytime that you clone this, this folder will start out as empty. And so you'll need to do the submodule update.
Gotcha. And I noticed that it's a CMD file, so ML.NET is cross-platform. So does that mean I can only build it on Windows, or?
No, so I was about to cover that. We have CMD, we also have a build.sh. Obviously, it won't run here if I try and run it. We support Windows, Linux, and Mac. We are actually in the process of making this work on ARM and ARM64. So that will eventually include the new M1 Macs. This currently doesn't run on those because they're the new ARM processor, as well as any other ARM device, Raspberry Pis, whatever it may be. So that's currently in the works. It's not there yet. But eventually we would like ML.NET to be able to run anywhere that .NET Core can run. And so that is currently in the works. Yeah, so then once you've done the submodule update, you can just go ahead and click run build. Now, you have to build it from the command line the first time. It's also recommended that you build from the command line anytime you have massive file changes. So if you're going from like an older version of ML.NET to a newer version, like you checked out a whaled version to test something, or if we push some big changes. And the reason for that is just because in Visual Studio itself, when it runs the build, it doesn't actually build our native C++ components. Only our command line build does. And so the first time you run this, or the first time you build, you do need to remember to build from the command line. Now, I've already built it here, so this build process should go faster than the normal first-time build, but even still, it usually, like the very first-time build only takes probably 4 or 5 minutes. It's not very long. So while this is running, I'll just let it run in the background. But I want to talk about a couple of the main kind of ideas or components behind ML.NET. And then we'll actually move into some of the actual code. We'll get hands-on and take a look at some of the more in-depth stuff. So first thing, if you've ever used ML.NET before, I'm sure you've seen this Idata view. And the Idata view is one of the main components of ML.NET. It is how we deal with all of the data, including the input data into the machine learning pipelines, as well as the output data. Now, the Idata view is called a view because it is very similar to a SQL view, if you want to think about it like that. In SQL, you have the tables, right? You have the data, you can change the data, you can do whatever you want. But a view is just like a query that's run on top of that table that brings back a very specific subset of those results. Now, those results that are returned can't be changed. You can use that in another view. You can kind of compose multiple views together. And the same thing is true with an Idata view. You get the data back from the view, and you can pull the data out and you can change it, but it doesn't change any of the data in the actual data view itself. You can compose multiple data views together through multiple pipelines. It's actually pretty cool. So this is going to be one of the main things that you will run into and see as you're working or using ML.NET. Now, one thing about it, and I'll talk more about this in depth a little bit later, ML.NET is what's called a lazy application, meaning it only processes things that needs to be processed. So if you have 1 million columns in your input data set and you only need 10 of them, it will only deal with those 10. And if you have 1 million input rows, but you only want to run 5 of them, it will only run those 5. It does not process everything that it doesn't process all of the input data. It only processes the very specific columns and the specific number of rows that you tell it that you need. Now with that, we do have this method here, get row count, but because it's lazy, row count may not always return a value. Until we have figured out the row count, which is usually after processing, this value will just return null. We don't know what the row count is yet. We ask again once you've done the processing. We can tell you when you're done how many rows we did. But because of this lazy method of evaluating things, oftentimes get row count won't return anything at the beginning. So this is one of the main pieces. And we're going to talk more about the lazy stuff because that is where, at least in my opinion, one of the things that is most interesting about this, that makes it very efficient to run. but can also be a little confusing and harder to kind of figure out where the processing is happening because of that. But before I get into that, let me talk about the other couple of main components. So we have an Idata Loader, which is what takes in the data, and it will turn that into a data view that then the pipeline can process. Now, again, because the data view is lazy, when you tell the data loader to load in your data set, all it does at first is figure out the schema, what columns that they are, the type of data that's in there, and that's it. It doesn't load in the data yet. Nothing happens. And
do you have some examples of Idata loaders?
Yeah, so we have several different Idata loaders, and I can actually show some here. I was going to go into this a little bit later, but we can actually load directly from an enumerable. So here we have basically a list of this sample input data that we've made, and we can actually take this list and turn it into a data view using a data loader. So this load from enumerable is going to, kind of behind the scenes use a data loader to do that. We also have data loaders that can read from text files, whether it's like an actual text file, whether it's a CSV, TSV, whatever it may be, you can specify the encoding. We have a SQL data loader. I think there's one or two others, but I can't think of them off the top of my head.
And let's say that I had a web resource, and I don't know if maybe it's in Azure Blob Storage or something like that. I don't believe that that's an option currently in ML.NET. But if I were to want to build a data loader myself, what would I have to, I guess, go into code and modify, or how would I go about building my own data loader?
Yeah, and we actually have some examples showing building a custom data loader. If you look in, so say we go back to the repo here, inside this docs folder, we have a lot of documentation about it, but we also have a lot of samples in here. You can come in here and there's a lot of different samples. So this sample, for example, shows you how to make an iData view. So there's a lot of good things in here to look at. So there's more specifics in here, but the easiest way would be to actually look at the text data loader that we have, which let's see if I can find it off the top of my head. I can't remember the exact name of the file that it's in. And of course, Visual Studio is not going to want to help me because it never wants to. Text data loader. Okay, well, I'll find it here in a little bit, but it will then show you how to do that. At a bare minimum, you only have to implement these two methods, load and get the schema of that data source. Now, right, it talks about here, and we've talked about this before, iData views are lazy, so we don't actually do the loading here. So it would require you to implement the loading in a lazy manner where you only get the data when it's requested, which is why looking at the text data loader would be probably the easiest way to go about it. But like I said, we do have some samples that go over some of that stuff. Specifically that one with the iData view, it actually creates a sample data view from scratch so that you can see how it's done.
Cool.
So yeah, iData Loader, one of the main things, right? And then we have two other components. We have a transformer and we have this estimator. Now the estimator, okay, let me do the transformer first. So the transformer is what actually transforms the data, right? That's why it's called the transformer. Its job is to take the input data, perform whatever transformations have been requested on it, and then spit out not only the schema for that, right? We can get the schema, but also actually the new iData view based on those transformations. Now, ML.NET, because it is built with this lazy approach where it only, well, not because of that, but one of the things, since it is built with the lazy approach where it only processes the data as needed, ML.NET loads in the data with the data loader in a streaming fashion, meaning it'll load in one row, or if it's running in in parallel, right? It can load multiple, but it'll do essentially one row will be loaded in, that row will be processed. You can use the data, and then we'll move on to the next row, so on and so forth. Now, this is great because it saves memory. It means that you can actually train on data sets that won't fit in memory. You can train, using images, and you don't have to load all the images into memory at once. It's really great. And because of that, we have this concept of what's called a row-to-row mapper. And a row-to-row mapper essentially just says, if you have one input row, do you also have one output row? Is it a one-to-one relationship? And when it is a row-to-row mapper, there's some nice advantages that we can take, that we get because of that. Now, the transformer, though, many of the transformers need to be trained, right? You need to figure out what the weights of the model should be, various things like that. So we have this estimator. And the estimator is what will figure out, right, what those weights should be. And then when it knows what those weights should be, it will output the transformer with those weights preset in it. Okay, any questions so far? No?
Oh, yeah, I'm not seeing any in the chat. So taking a bit of a step back. So the estimator is sort of like the plan for like the operations that you're gonna perform, right? And then once you call the fit method here, it will produce a transformer, which is going to contain what it's learned, like you mentioned, the weights that can then be used for, and to take a step back, a transformer can also be a set of transforms, right? So it doesn't necessarily have to be an actual machine learning model like a trainer. It can also be just standard transformations like concatenation and
That's correct.
Filtering, things like that. Okay.
Yep. So suppose, for example, you wanted to subtract the average value from a column, right? During the estimate, like the estimator itself would figure out what the average is of that input data set, right? Whatever column specifically we're looking at. And then it would make a transformer that would say, hey, the average value is 5. So then when the actual transformer runs, it already knows what that average is, and it can just directly subtract 5 from all of those input values. So the estimator is what does, figuring out, like I said, the weights in that example, right? The average, mean, whatever you want to find, and then the transformer would actually do the actual work of subtracting that value.
Gotcha.
Okay, so now with the Idata view, because I'm going to go back to this, you'll notice that if you read the names of these methods, right? Can you shuffle it? What's the row count? Get the row cursor, right? Get an array of row cursors, and what's the schema? There isn't a method like, hey, give me the data for this column, right? And there's a very good reason for that. Now, the way that getting the data is actually implemented is with this row cursor method. And this threw me off a lot when I was actually first getting into ML.NET. This is due to the lazy nature of how ML.NET works, and it just took me a while to kind of wrap my head around all of it. Originally, if we go back to the beginnings of ML.NET, before I was on the team, there was a method on the data view to get the data from the column. Problem is that because we do it in this lazy manner, or not the lazy manner. Well, yeah, the lazy manner. Every time you said, give me the data for this column, it would check, does the column exist? Is it active? Because since we only process columns that you specifically request for, if you train on like 5 columns, and then at the end you say, give me this column I didn't train on, right? That's not going to work. So we'd check, okay, does the column exist? Did you actually use it in the training process, right? Various checks that needed to happen. Because we load in one row of data at a time and then process it, those checks had to happen every single time we called, that method, give me the data. And as you can probably imagine, that's not very efficient performance-wise, right? Especially for transformers that were mostly just copying data, right? Like the column copying transformer, for example, that all it does is duplicate a column. It was very inefficient. The majority of the time was spent doing these checks and not actually doing anything with the data. So what they decided to do to change that was we use this row cursor, and the row cursor has a method, the data view row, which is a subset of that, has a method in here somewhere called getGetter. And getGetter actually returns a delegate. Now, for those of you who don't know what a delegate is, it's basically a function that you can kind of pass around a reference to the function so you can use it wherever you want to use it. So getGetter returns a function. But what that lets us do is when we call the getGetter, we can actually check all of those conditions that need to be true. And then only after those conditions are all true, we can actually return this delegate here. Which means that inside this delegate, we no longer need to check those conditions. We've already confirmed that the conditions are all correct. And so this means that we only check the condition the first time. And so for some of the more simple operations, like the copy columns one, it actually sped it up by an order, by several orders of magnitude, because it went from checking every single row to checking once, verifying that it's correct, and then never having to check again. So that's why there's no, when you look at the iData view, there's no method like give me the data for this column.
Now,
does that make sense?
Yeah. Now, this getGetter, is it something that you define? Like you have to specify, tell it like here's the logic for the delegate, right, that I'm going to be using, or is it something that's already built in and that you can just, it's just another method that you call that's built in?
Yeah. So it's fully built into ML.NET. If you add a new transformer to ML.NET, you would have to write this getGetter method. But for anything that's in ML.NET already, if you're just using it as a library, that's all built in, and you don't need to worry about it at all.
Cool.
And we'll actually show an example of that. So this file here, this is in our samples project, which, as I mentioned before, under this, we have our docs. There's docs right here. Under there, we've got, besides a bunch of documentation and API references and stuff like that. And by the way, all of the stuff that I've been mentioning, it exists in this folder and in way more depth. So if you're interested in that stuff, you can find all those things inside of here. It's actually really interesting, a lot of the design decisions, like why they were taken and what they are. But inside the samples here, we have a lot of these samples. So that's where I'm getting this concatenate sample from. Now, all it's doing is it's going to show an example of concatenating columns into one large column. And I picked this one because it's simple enough that we can kind of ignore the fancy machine learning stuff and actually just look at ML.NET and how it's working. So, first, as we looked here already a little bit, this takes this data that's here and loads it using a data loader from this enumerable value, this list, which returns this iData view that we've been talking about. Now, ML.NET, its pipelines, they are meant to be chained together. So we can see here, the first thing that this pipeline is doing is it's actually converting column feature 3. So if we look here, we have this feature 3 right here, right? Now, if you look, this is a float, this is a vector of floats, and this is an integer. So the first thing that we're doing is we're actually converting feature 3 into a float. But then because all of these transforms in ML.NET is made to be chained together, we can just append another transform. And this is the one we're going to look at, is this concatenate one. So we're going to concatenate into the column called features. And for its input, we're going to take those 3 input columns. We're going to concatenate all of them into a single column. Now here, we have the fit call, which is the estimator that says if there's anything that needs to be learned, which in this case there's not. So in this case, fit is a no operation, It will not do anything other than just return the transformers. And then transform will just make sure that the schema is correct, but it won't actually do any of the transformation. Now here we have some helper methods. So I talked about the get row cursor. We actually have this method called create enumerable that kind of masks that a little bit, that it will just give you back an enumerable and do everything behind the scenes for you. but I'm actually going to go through and get the row getter and walk through what it actually looks like if you want to do it that way as well. So let's actually, I'll just go ahead and do that first. So we have our Idata view, transform data, and we want to get a row cursor, which is very similar to a cursor in SQL, right? It allows to iterate over the results one at a time. Now, cursors only move forward, but Idata views are guaranteed to return the same data no matter how many times you iterate over them. And so you can have multiple cursors opened to the same Idata view. And each one can actually request completely different columns if you want to, and that's okay. Now, because of that, though, you'll see that this needs us to pass in an enumerable columns needed. So we're actually going to give it, I'll just make a list, right? Now, the column that we want to get for this case is we want to get the one that we've concatenated together, this features column. So just to make it easy to get, we can actually take the output schema from our Idata view and access it with array notation, and we can say, I want to have a column called features. Now this will go ahead and give us our cursor. So now we have this cursor, and because we're concatenating multiple columns together, we know that we're going to have a vector of whatever type these columns are. These columns, right, when we look at the input data, we know that they're floats, so we're going to have essentially a vector of floats. So we're going to say cursor.getGetter, and we know that it's going to be a vector of floats. Now in ML.NET, our vectors are called vbuffers, which supports a sparse notation, essentially. So if you have like 1,000 columns, but only 4 of them have values, you can actually use this and only have to store 4 values instead of having to store the other 900 zeros that are there. Float, and then I want this, the column that I want is the features column. So now we have this getter. Now with the getter, you have to pass in whatever type it is. So this is a vbuffer float, it's a vector float. So when I call the getter method, I have to actually give it an empty vbuffer so where it can load the data in. This means that we only have to allocate the data to store the results one time. Now, if the size of the vector is dynamic and changes, you may have to allocate a larger one in case the one that's allocated first is too small. But eventually, once you've hit the largest size you need, you won't have to reallocate memory every time. So we can go ahead. So let me create our vbuffer that we can get our results. And now, because it's a cursor, like a SQL cursor, right, we have to loop through it. So while getter.move next, oops, sorry, not getter, while cursor.move next, and you just say results, and I will pass in our, oops, not results, my apologies. We need to call our getter, and we need to pass in the results to that getter. And this will loop through and one at a time get those results. So it'll load in one row of data, do the transformations on it, and then spit out the results. So again, we could have a text file here that was, 100 gigabytes, which would be a huge text file. But anyways, we could have one that size, and even though it wouldn't fit in the memory on my machine, because we're looping through in this streaming fashion, it would still work just fine. We wouldn't have any problems with that.
This is kind of interesting. I'm not sure I've seen this sort of pattern before, where you're kind of like moving the cursor, but then the getter sort of has that reference to the cursor itself, so it doesn't need to be passed every time. It's just a part of that cursor. So yep, that's kind of what's happening here right on 61 and 63.
Yep, that's correct. So because we used the getter here, or the cursor to get our getter, whenever cursor.moveNext is called, the getter will automatically be updated. So in fact, if we wanted to, right, we could call cursor.moveNext here, not that you should, because this would end up skipping rows because we're now calling moveNext twice. So it will just automatically update because the getter was created from that cursor, it will automatically change. So you don't have to do anything with the getter to say, hey, move to the next row. This takes care of everything. And move next will return false when there's no more data. So you don't need to worry about like, oh, am I going to throw an exception if I get past the end of the data? Nope, it just returns false. So you can then just move on safely when that returns false.
Now, you mentioned that you are able to have multiple cursors pointing to the same data view.
Mm-hmm.
Depending on what it is, maybe you want to get different columns each time, whatever it may be. Is there an impact in that case, though, than if you're sort of iterating over multiple cursors? Well, first of all, could you iterate over multiple cursors at the same time? Or in this case, right, it would first evaluate the first cursor, and then, maybe if you're doing some other operations, another cursor, you'd have to wait until this first cursor is done.
Yep. So yeah, let me go in a little bit into that. So right here, when we say we want the features column, ML.NET will trace from the end of the pipeline to the beginning to figure out what input columns are needed. So it knows that it needs features 3, and it knows that it needs features 2, and then it needs features 1. And then it will continue tracing backwards, and it will say, hey, features 3 needs to also have this conversion happen, because that's what we're saying right here. So by saying just in this one cursor location that we need features, it will trace back and figure out that it needs to process this transformation right here, and that it needs to process this transformation. So if we actually removed features 3 from this list, and we said, oh, we're only concatenating features 1 and features 2 together, this first transformation of features 3 will never happen because it's not needed to get the column that we want. Now, because here we're only specifying that we want to look at features, the only thing that we can get from this cursor is the features column. But what we can do for answering your question is we can also say, I want to look at features and I want to look at features 3. So now with this one cursor, we can get features and features 3. So we need to do the same thing where we get the getter. So let's go ahead and duplicate this line, and we're going to call this just getter 2 because it's easy. And here it's no longer a vector, right? Features 3 it's originally an integer, but because of the transformation that happens, it's going to be just a normal float. So we'll go ahead and say that's actually just a float, and we want this to be features 3. And so here we have 2 getters that are going to use the same cursor as a backend, right? But and then in here we could say getter 2. I need to have a float. Let's see, float. I'm going to call it result float, and we'll just set that to 0 for now. 0. And so here we can say results float, and we can now get both of these getter values from the same cursor. Now, Luis, you were also asking about 2 cursors for the same data. So if we wanted to do that, let's remove features 3 from this one and just leave it as the normal features. And then I'm going to duplicate this line here. And let's say now we have cursor. I'm going to call this cursor float. And we only want, let's just say we only want features 3 for this one. So now we have the same underlying data set, but we have 2 different cursors that are pointing at it. And each one is actually referencing different columns. Now, if we ran it right now, this will actually fail, right? Because we're still using the original cursor here to get features 3, which is not supported. And so we want to make sure that we update this value. But then what you can do to move through both at once is we can say cursor float .move next as well. Now, as long as both of these can move forward, we will continue to get their values from here. Does that answer your question, Luis?
Yeah, it does. Yeah, it does. Thanks.
Yeah, so we can have as many cursors as we want into a data set, and we can have as many getters as we want into a data set. In fact, you could make multiple getters that get the same column if you really want to. There's no real point for that. It's much more likely you use multiple cursors into the same data set rather than using multiple getters, but you could do that as well if you want to.
And in this case, the cursors and the getters, they're focusing on the columns, but
That's correct.
Is there a way to say, like, maybe partition the data set at the row level using these cursors? And the idea there would be, let me take, I don't know, the first 1,000 rows and like have model train using only the first 100,000 rows, and maybe the next 100 rows or whatever, I'll use another cursor that's pointing to the next set of rows and train another model. So kind of like have an ensemble and partition the data that way. Is that possible?
So the way that I have done that in the past with the data loader, you can specify you want to have like a train test split. And so the data loader itself will handle that. I myself have never just said, let's take this iData view and partition it by like 1,000 rows at a time. But you can, there is a way to do that. And actually, if we come back to the iData view here, this getRow cursor set actually returns multiple cursors that automatically partition the data. And it can be done in a random method, right? You've got this random here, so you can either have it shuffle the data for you, pull them randomly, or I believe as well you can have it just do, like you said, the first 1,000, the second 1,000, the third 1,000, whatever it may be. But what controls all of that is the how parallel you want it to run. And so if there's 1,000 rows and you say I want 10 threads, it'll do like 100 per thread. So you would have to actually do some math there. Mm-hmm. But you can get multiple cursors out from the same thing and have them split up.
Interesting.
Now I know we're close to running out of time. So one of the things I want to show real fast with this, if you actually run this, you'll notice that this getGetter method is called multiple times. And that sounds strange, right? Because getGetter should only be called once, right? Because that was the point of having these delegates, these functions returned, is that we don't have to check the output multiple times. Well, what's going on is that under the hood, we check and we say, can we run this in parallel? Is there a problem if we run this in parallel? And if there's no problem with running in parallel, ML.NET under the hood will go and run this in a multi-threaded approach to get a speed performance boost without the end user having to do anything. It will automatically figure out, is that okay? Is it safe to do? Is it not? Whatever the situation may be, and do that for you. So if we ran this, we would actually see that gets hit, that it hits this method multiple times just because of that. But the good thing with that is it'll only do it still once per thread, but then we get the benefits of running in a multi-threaded fashion without us having to actually worry about programming that ourselves. So
we have one question here in the chat, and I think this was related to the transformers back when you were talking about that. It's from an anonymous user asking, is there a possibility or option to have middleware to encode and decode with the same context for like BERT with embeddings? An anonymous user, maybe you might want to clarify that a bit. I think what's meant there is maybe using a transformer for encoding and decoding. And anonymous, maybe you can clarify that. So I guess the question, or how I would interpret the question, is, can you basically build your own transformer for encoding and decoding?
The same context. Yeah, I don't think I fully understand the question. I mean, so everything that's here, right? The estimator and the transformer interfaces that are here, they're all public. So anybody can actually go ahead and extend these estimators and transformers to do anything that they want. So I believe that what you're asking is probably possible, but I don't understand. I don't think I understand exactly what you're asking. So I can't say yes, it is, and I can't say no, it's not possible. But just because you can fully extend these yourselves if you need to, you can do a lot of stuff if you're willing to actually implement it yourself.
Gotcha. Thanks.
So, it looks like Robot Stevie, you asked if this code will be hosted anywhere. So all of this stuff is in the samples. This specific stuff that I've written here, I'm happy to make a branch in my fork of ML.NET if that would help. But there is lots of samples of this, basically this exact same thing inside the samples repo, and even a bunch of our test cases will use this as well. So you can either use this cursor pattern like we showed here, or this create enumerable will do all of that stuff behind the scenes, and you can just make a class that says, this is what my output data looks like, and it will do all of that mapping and everything for you. So you can see here, you just say, this is the type of data, here's my iData view, and then reuse row object just says, should I reuse the memory or not? So this is actually much easier for an end user, and if you don't need very specific control over it, it's probably easier to use. I prefer showing this the first time because it shows what's actually happening, which makes it, in my opinion anyways, easier to understand what it's doing. Less less of like hand wavy magic stuff that's happening, and more of this is actually what's happening, but here's some additional ways that make it easier for you.
So I have a bunch more questions, but I was actually thinking maybe what we should do is have you on the show again. But I think at a high level, I think this helped a ton. I guess if we could kind of just sort of summarize a little bit on, why we spent time on the iData views and the iTransforms and the iEstimators, like how they all kind of fit together.
Yeah. So
put a bow on it.
Yeah.
Go ahead.
So quick summary, right? For that, like you said, the iData view, the estimators, and the transformers are the backbone of ML.NET. The iData view, with its streamed data and lazy data approach, make ML.NET be able to run in a streaming fashion, and everything, right, is built around that. And then the estimators and the transformers are what do all of the actual work. Now, I took a little longer going through the example than I wanted to, but if you look here, this is in the column concatenating transformer, just what we were just looking at. If we actually look at like the transform method, well, actually, let's look at the fit method. Where's the fit method? For the estimator, that might actually be in a different file. Yeah, we'll look right here. If we look in this file and we look at the fit method, you can see the fit method does nothing. It just returns the transformer because of that lazy approach. So my goal was that by going over these things, because when I first started this, I would be running fit and I'd be saying like, why is nothing changing? Why is nothing happening? I don't understand, right? When I'd call transform, nothing was changing, and I couldn't figure out. It took me a while to figure out, anyways, where actually that processing was happening, and it's because it's happening in that get-getter method and not in transform and not in fit. So the idea, I guess, at the high level was to go over those three to show how they're the backbone of ML.NET, but also to show, hey, when those actual transformations are happening in that get-getter method. So don't look in fit, don't look in transform. It's not going to be there, right? It's just in that get-getter method. Does that make sense, Jake?
Yeah, thank you very much.
We've got maybe we have time to answer. It looks like anonymous user clarified, and then we've got another question from Amit. So let's maybe look at this one first, Michael. Is there a possibility to update set of values in the 1000 data that was fetched by the get cursor method?
Is it possible to update? So when you get the cursor, the cursor cannot, you can, when you get the data back, you can then change it. But if you change the data, it doesn't affect the underlying data view. So if you had two cursors on it and you pulled the data from one cursor and then you modified it on your end, the second cursor wouldn't get those changes because it's not actually updating the underlying data view. It really is just like a SQL. It really is just like a SQL view where it doesn't change the underlying table. So it depends on what you mean by update those values. You can change them on your end, but it won't actually change the underlying data values. If those need to be changed, it would need to be changed through like the transformers in the pipeline itself.
Right. And here's a clarification from an anonymous user. So to clarify, I mean, when one row has metadata, for example, words that are converted to embeddings, and you want to decode the prediction back to the original text again with an Onyx transform in between.
So if I'm understanding you correctly, I believe that we support that. We have something called like a key to value mapping and a value to key mapper. So the value to key mapper will take in a bunch of words and will embed in the metadata, right, what the mapping is between like the key, right, the integer value that's there and what it actually is. And then in the end, when you get the prediction back and it says, hey, the prediction is 5, we can then map that 5 back to what the original word was in the input data. So if that's what you're asking, yes, we support that, and that is already built into ML.NET. And I believe that's what you're asking based on how I'm reading your question. But if that's not what you're asking, then maybe I have some understanding. But yeah, if I'm understanding correctly, then yes, we do support that. And just real fast, Matthias, with what you're asking, we do support CUDA for like if you're using the TensorFlow models for image recognition. As long as you get the TensorFlow DLL file that supports CUDA and you have the correct CUDA stuff installed, it will take advantage of that. Yeah.
We also have it in Model Builder. If you go to image classification, there's a GPU option, and that'll take you to documentation on how to set up your machine and get going with GPU training.
Cool. Look, I think we answered all the questions in the chat. So thank you everyone for joining us. I know we're about 6 minutes over. So thanks for bearing with us. And yeah, thanks a ton, Michael, for walking through that. We'll definitely have you on again. I know there's a lot of content you wanted to get through. And of course, if anyone here has unanswered questions or wants to reach out, Louise and I are on Twitter. Also, then you've got the GitHub, of course, which is in the URL list links. Louise has his Twitter handle in his name right there. Anything else, Louise, Jake, or Michael, that you wanted to end with?
No, this was great. Sorry, go ahead.
I think that's it. Thanks, Michael.
You're welcome.
Cool.
Thanks.
Then we will see you all in 2 weeks.
All right. Take care, folks.
Bye.